Hey, good morning. It is Tech Mornings with the Tech Prepper, Episode 6, Deploying Peregrine to Google Kubernetes Engine, Part 2. Before we get started, let's review the objectives. First, we're going to install gCloud SDK. This is a series of command line utilities that allow us to interact with Google's cloud platform. Second, we're going to look at Helm. Helm is an application designed to help manage applications running on Kubernetes clusters. And it consists of two parts: the Helm client, which runs locally, and the Helm server, which is called Tiller. Tiller is deployed as a pod to your Kubernetes cluster. Next, let's talk about some Kubernetes resources. Kubernetes can be challenging. In fact, I had a hard time grokking Kubernetes at first, but there are two resources I found valuable. The first is an excellent YouTube video called The Illustrated Children's Guide to Kubernetes. There'll be a link at the bottom of the screen and also in the description. The second one is a book from Manning called Kubernetes in Action. The book is a bit dated, but I found it very useful. And with that said, let's talk about next steps. So in this video, we're going to go through this exercise, and unfortunately there will have to be a part 3 and a part 4. In part 3, we'll actually go ahead and use the Peregrine Helm chart we've created and deploy our 3-pod application out to our cluster. So that is the Peregrine stateful pod with persistent volume, and then the 2 Apache pods, the live and stage pods, along with all of their services and configuration. And that will quickly allow us to interact with our application on the public internet on Google's cloud platform. The part 4 video will actually involve a teardown of that environment. We'll go ahead and recreate it, and I will actually go through the end-to-end process using gCloud to provision IP addresses, SSL certificates, and also deploy a hardware load balancer that will allow us to have SSL termination, and then we'll go back through the Peregrine deployment. So at the end of that, at the end of part 4, we should have the ability to have our application fully secured and available on the public internet and hosted on GKE. So with that said, let's get started, guys. All right, so let's start by installing Google Cloud SDK. And the first thing I've done is I've gone to cloud.google.com/SDK/install. Now it's been about 6 months since I've gone through this installation, but I am trying this out on a new Mac, so I'm basically doing with this live with you guys for the very first time, or I guess the second time. And it looks like there are a number of installation options. Since I'm on a Mac, I'm going to go with the versioned archive, and we'll click through. And it looks like we need to download a version of the archive that is compatible with our OS. In my case, it looks like it's going to be Mac OS 64-bit. So I'll copy the URL to download the file to my clipboard, and then I'll open a terminal window. And I typically like to install everything in my home directory under a directory called opt, and I'll fetch that file with curl. And the -L will just follow redirects, and the -O will save the file using the name that's in the URL. Let's go ahead and unpack that tarball. And then I'll run Google Cloud SDK install.sh. And it looks like they're asking us to send information to Google. Nope. And they're asking for permission to change my bash profile probably and set my path. I'm okay with that since I already have a backup. Yep, and it looks like that's exactly where it wants to write it by default, is to .bash_profile. And I'm curious to see what they've done to it, so let me quickly inspect my bash profile. And it looks like they've added these 5 lines here. So I'm okay with that. So since they've written to it, I'm pretty sure if I do which gcloud, yeah, it's not working yet. So I can either open up a new terminal window, or we can go ahead and source the bash profile. So we'll go ahead and specify dash profile. Perfect. And now if I rerun the gcloud command, let's see if, perfect. All right, so we've got gcloud now in our path. The next thing we need to do is figure out what the next step is. And it looks like from here, we just need to run gcloud init. All right, so at this point, I do recall this step. They're going to want us to log in, and I'm pretty sure it's going to open a web browser and then have me log into my Google account. So we'll go yes. And I can select all of my accounts. So I'm going to use my Tech Prepper account. And then it looks like we need to give permission to the Google Cloud SDK to my account, and I'm fine with that. And it looks like we're now successfully authenticated with the Google Cloud SDK. And now we can actually pick our cloud project. What's interesting is that this is brand new. I have not seen this before. In the past, I actually had to configure this by hand using the gcloud, a set of gcloud config instructions. So this is pretty neat. Let's go ahead and enter number 2 so we can use the Tech Prepper. And we do want to configure a compute region and zone. And as I mentioned before, I'm in the US and in the West Coast region. I typically use US West 1A. So for us, that's number 13. Okay, so there is a command here that I ran the first time. And I ran gcloud container clusters get credentials. And this should be the name of the cluster that we set up the other day. And I think we called it the Tech Prepper number 1. And let's see what happens now. Okay, so this is perfect. So this was the command that we needed. So we ran gcloud container clusters get credentials and then the name of the cluster that we set up in GCP or in GKE the other day. So now, if I run kubectl get nodes, it should return exactly one node that's in the cluster. Perfect. So as you can see here, we're good to go. We can actually now use kubectl to start deploying pods and other Kubernetes services. One thing I will mention, I'm going to use the shorthand. Instead of using kubectl, I like to alias kubectl with k get nodes. And this is pretty common practice for anybody who's worked with Kubernetes. I can actually show you a line in my my profile that I have, and it's just a very simple alias instruction. So I recommend anybody who doesn't want to type out kubectl every time, just add to your profile alias space k equals kubectl, and it'll really simplify your life. Now that we have the gcloud SDK installed and kubectl configured, it's time to install Helm. And Helm is a package manager for managing Kubernetes applications, and it consists of two parts: the Helm client that runs on your system, and the Helm server, which is called Tiller. And Tiller is deployed as a pod to your Kubernetes infrastructure. All right, so let's get started. To make things simple, we have a GitHub project that we'll demonstrate in tomorrow's video, but there is a convenient wrapper script called install-tiller.sh, and I can't recall if I created the script or if I found the script online, so my apologies for not giving credit where credit is due. But this script is basically a simple wrapper around multiple installation steps for Helm and Tiller. The first thing it does is download the latest version of Helm and Tiller locally, and then it basically performs the installation. The rest of it performs kubectl commands to deploy the Tiller pod to your running Kubernetes cluster. And we'll discuss this more in episode 7, part 3 of this video, the day after next. So to begin, we're going to fetch that script with curl. Next, we'll change the permissions to make it executable, and then we'll run it. It will prompt you for a password as it will try to install Helm locally in user local bin on a Mac. And one thing to note is that it's installing the latest version of Helm at the time that this command is run. As of today, it is Helm v2.16.5. And since I'm on a Mac, it's pulling down Darwin AMD 64. Now that it's done the local installation, it's deploying Tiller to our cluster. So it's important that we have a running kubectl configuration running locally. And as you can see here, it's deployed a service called for Tiller, and as well as a pod. A couple things to note really quickly here. If you take a look at the deployments, you can see it says 0.1 ready. It means it's still in the process of deploying it. So a quick way to test this is to run k get pods all namespaces. I think it's all dash namespaces. Yeah, and you can actually see now that it has deployed the Tiller pod for us and that it's in the ready state and it's currently running. The other way of testing to make sure we've done this correctly is to run Helm version. And Helm version will return two things. One is the client and one is the server. So before moving on, make sure that you see both the client side and the server version listed. So at this point we're done and we're ready to use the Peregrine Helm chart to deploy our application. That video will take some time, so I'll reserve that for part 3. One thing to note is we received a comment from a subscriber, Zan Nick, and he actually recommended a application I've never seen before, and it's called Lens. And Lens is a cool IDE for Kubernetes, and it's available at k8slens.dev. So let's take a look really quickly at Lens. The first thing you want to do is click the plus icon on the left. And since we do have a valid kubeconfig configured, you should see our cluster listed. And then select Add Cluster. And at this point, you basically get the same dashboard as you see in the GKE console. So we can see our clusters, we can look at workloads, we can take a look at all of the services deployed, applications. So we don't have a whole lot installed here. So let's go back and we can look at our pods. And what this is actually doing that's a bit different than the way I run it, it's actually using the all namespaces. So it's bringing back system pods and resources. I'm not likely to use this for the management of my cluster. I prefer to use the command line and interact with the Kubernetes cluster this way. It's more natural to me, and I actually have a better understanding of how things work. But where I will use this is to take a look at things like CPU, memory, and disk metrics. It just makes sense to visualize data graphically. It's not really well suited to looking at the terminal for that. I hope you guys have enjoyed this video. In tomorrow's video, we'll take a look at actually using the Peregrine Helm chart, deploying a stateful Peregrine pod and its services, and 2 stateless Apache pods and its services to our GKE cluster. We'll have a part 4 after that, and the reason for it is I don't want to complicate the next video to deal with things like cloud provider specific load balancers and SSL termination. Instead, I just want it to be an opportunity to throw a non-secured version of the application into the cluster. At the end of that video, we will tear it down, create a new cluster, and then we'll go ahead and do a deployment via Helm with gcloud using all of its utilities. So be strong, be safe, and think about using gcloud and Kubernetes. Thanks, guys.